Okay, we are live now.
I should start.
Yes, ma'am. Yes, ma'am.
Okay. A very warm good morning to all the participants. Here we are again today in the 10th day of this 2-week faculty development program on research methodology. In these past days, we have learned quite a lot about qualitative research. We talked about what is research, then how to find out appropriate journals, their impact factors. We have also done hands on with Overleaf, with which we understood how to use LaTeX to create our documents. It has been an insightful journey, and thanks a lot for all the good feedback that we have got. I think everybody is liking the content. Today, we are again here to deliberate on the topic quantitative research. We have with us Dr. Arnav, who will again give you a brief about the basic fundamental concepts in quantitative research and will also show you a little bit of hands on with dealing with data and how you can use quantitative data while you are researching. So, Dr. Arnav Kumar is currently Assistant Professor in Department of Commerce and Management Studies at Ramanujan College. He has done his post-graduation and doctorate from Department of Commerce, Delhi School of Economics, having a rich experience of around 7 years of teaching postgraduate and undergraduate courses in management and commerce. He specializes in research methodology, statistical methods, software packages for research, and has teaching interests in finance and investments. A vivid researcher, he has published 16 research papers in national and international journals of repute, including ABDC listed journals, and has presented research papers in about a dozen national and international conferences and seminars. He has received 9 Best Research Paper, Project, and Presentation awards at different national and international conferences. He has provided consultancy in major UGC, ICCSR, and DU innovation projects. He has also undertaken around 30 sessions as a resource person or invited speaker in MHRD sponsored national level FDPs, workshops, and 1 month FIP orientation programs at institutions such as SRCC, Hansraj of DU, and also in various B schools besides others. So he has actually got a lot of experience and knowledge that he can share with us today. I welcome you, Dr. Arnav. Thank you so much for sparing your time for us. And I hope we can definitely deliver nice interaction and knowledge to the audience today. Thank you for being with us. Over to you, sir.
Thank you, ma'am. Thank you for this kind introduction. And thank you to my colleagues, Dr. Ashish, Dr. Sachin, Vipin sir, and you also, Bhavya ma'am, for providing this opportunity. And in fact, learning about what all has been going on in this FTP, it further, satisfies me that what vivid contents you have already covered. And thank you for giving this opportunity of fitting in this quantitative research session.
The stage is yours now.
Sure, ma'am. So, dear participants, welcome. Ma'am has already given an introduction and you are already familiar with the topic. So, what we are going to talk about today is quantitative research. And as you would understand that even whatever time we allocate is not will not be able to we cannot do justice to quantitative research because it is like an infinite ocean. It has several areas, several dimensions, several branches, sub branches. First it emerged from statistics, then we have separate disciplines for, say, cross sectional studies, for time series studies, for panel data analysis, even for say discipline specific studies like biostatistics. So quantitative research is very, 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 very exclusive and wide, and I cannot cover everything. But as Bhavya ma'am have pointed, and as is the vision of the organizers, what I will like to do in this 1.5 hour session is that I will like to cover up some of the important aspects and basic concepts which you must keep in mind and understand while doing quantitative research. And then we will do some hands-on session and which will involve interpretation through data sets. So this is the idea. If you have any suggestion or comments later on or anything to discuss, you can reach me at this email ID. So we will start with important aspects of quantitative research. So we basically know there are several types of researches. You have already done this with in this program. So quantitative analysis and quantitative research occupies a special position. If I quickly give a glimpse of this, why it is relevant and especially relevant in today's time, if you look at whether it is scientific research, whether it is research in social sciences, either case, quantitative data-based evidence is required. For
Anuj sir,
example,
Anuj sir, there is a
yes,
noise. Means I don't know. There is some kind of noise. Could you check?
okay, I will try, sir. I'm not
Now it's
sure.
fine. Now it's fine.
Okay, okay. So this quantitative analysis, if I give two, three quick examples. So for example, there was entire awareness amongst people for the past 3, 4 decades that there is environmental problem, there is global warming, and there is all kind of uh, damages that human development has been doing to the environment. But there was no cognizance of it at the highest level. But when data-based scientific studies by people in different disciplines, including in economics, in environment, in geology, in other natural sciences, when they started coming up, even in agriculture sciences, that yes, climate change is impacting agricultural productivity, is causing melting of glaciers, is causing rising in sea levels, and this will have this much drastic impact. And we know that all major cities and commercial hubs are located on the seaside, whether it is Mumbai, Kolkata, New York, all of them are uh, on the riverside, so or seaside. So rising sea levels is a big problem. So when this data-based facts and researches started coming out, then only there was acceptance of this fact, and this led to a global climate deal in Paris, which I think all of you are aware of. And in that was such a deal that every nation, every head of state, you can imagine what amount of evidence and facts and supported by quantitative analysis of data would have been required to convince heads of almost all 210 plus states, 210 plus nations to agree on something. So quantitative analysis of data is the cornerstone. If I give another very quick example, many of you are from disciplines of economics, social sciences, including in commerce and management also. So many of you have heard about Raghuram Rajan, the former governor of RBI. So Raghuram Rajan was able to predict the global financial crisis that took place in 2008-9 beforehand because of his analysis and interpretation with the data. He could see that this trend is unsustainable. Financial assets and markets are overvalued, and there is a bubble and it can burst anytime. Another very good example in sociology and in anthropology, in political science, there is increasing use of quantitative analysis of data, even if it is simple techniques. For example, there is use of several things in gaining public opinion, taking surveys, taking feedback. You see one very good example is the reporting of results, survey results before exit polls, that we call exit polls before the actual results. Now election commission has banned it, so it is after voting is done, and after the voting is done but before results are announced, then we have exit polls. So what is it? It is based on sample data and analysis of that sample data, and also opinions and what is trending, what voters want. All of this feedback is getting into the system, and leaders talk on those topics. So quantitative analysis has a great place, and in academia, quantitative research carries even more value, whether it is in our job interviews, whether it is in our MPhil or PhD, or in getting a better grasp of reality and understanding of practical problem. Now, I will quickly go over a few basic concepts. One basic concept, one important concept that you must understand, two of the in fact important concepts regarding data. One is the types of data and other is scales of measurement. So type of data we can divide into time series, cross-sectional, and panel based on what is the unit of study, how many units of study there are, and what is the time dimension. So for example, if there are many units of study, like at a single point of time, for example, the common survey based, questionnaire based data, whenever we take nowadays in academics for NAC and other purposes, we also have to take feedback from students. So you're taking feedback from several students at one point of time. That is a cross-sectional data. You take opinion of people regarding political parties and elections, or any opinion regarding any leader polls, or any social issue. You take opinion of people. So that is again cross-sectional data. Some scientific data can also be cross-sectional. For example, if you measure, say, we have heard of sero surveys that are going on to measure the penetration of antibodies in our population. So you must have heard that the several rounds of sero surveys have been carried out throughout the country. Now sero surveys are also, data is also being collected at a point of time, usually few days, but collectively it is at a point of time, and they report that during this period this was the result of prevalence, and then they again go on to collect. In fact, so but if we talk about one point of time on which in which the data has been collected regarding this, again it is the cross sectional study. When we extend a single unit of time, now in this we are talking about, in the cross sectional study we talked about many individuals, many, say, political parties, many social organizations, many companies, if we go in commerce and business. So whenever there are multiple entities and single point of time, this is cross sectional data. But if we have a single entity, so for example, if we take COVID-19 cases of India, or COVID-19 cases of USA, or COVID-19 cases of world taken as one entity. So whenever we have one entity as the sample unit and we are measuring its variable over time, then it is a time series data. So if we are talking about one country's COVID cases over the past 7-8 months, then it is time series data. Now, please keep in mind that I have deliberately not put variables here, because in all of these three types of data, there can be multiple variables. Please understand that this is a very common point of confusion and misunderstanding. Some people think that if there are too many variables, then it is panel data. It is not so. Number of variables can be one or many in all these three cases. It is the units of study and the time dimension which segregates, which decides whether the data is cross-sectional, time series, or panel. In panel, we have many cross-sectional units, that is many units of study, and it is also measured over time. For example, if we continue with the example, so COVID cases, across COVID cases which we normally see of several countries measured over time. Several countries meaning we have several units of study, like in cross-sectional data, and measured over time. That means we have a time dimension, time component. So it is a panel data. So this segregation, dear participants, respected teachers and academicians and researchers, is very, very important, because when you know what type of data you are dealing with, then only you can find out the appropriate quantitative research techniques to apply on data, because different data sets have different characteristics. Now, while talking about panel data, I will also like to point you that intuitively you will understand that there can be, since panel data is a combination of cross section and time series. So for example, there can be a short panel in which there are more cross sectional units and time dimension is very less. And this is happening nowadays because of availability of data, that even people from social sciences, it was unconceivable a few years ago, up to few years ago, that people in social sciences will ever come across something like panel of a data. But nowadays, due to availability of data, let me give you a very simple example. For example, in political science or in social sciences, other disciplines, we measure human development index. Now, human development index is for the rankings are there for say 160 countries. Now 160 countries, if they are ranked for a particular year, so single point of time, so it is cross sectional. But now the report of, or the statistics of human development index is available over a period of time. It has been calculated and reported for several time periods, so it becomes a panel. So but since the number of cross sectional units, yeah, that is countries, is still very large, so we say that it is short panel or cross section based panel. And a time series panel would be in which there are only few countries but long time dimension. For example, BRICS data: Brazil, Russia, India, China, and South Africa. This is a popular grouping of BRICS, of emerging, prominent emerging markets. So BRICS data, if we take GDP or any financial variable over say 20 years, 30 years period, then the time dimension is very large while the number of units is only 5. So this is long panel or time series panel. So first and most important thing that you should understand on in your research is that which type of data you are using, you are going to use. So in hardcore social science disciplines also, we may encounter short panels or cross sectional panels, if we call them. In time series or financial economics disciplines also, we may encounter some cross sectional data. For example, the forecast of GDP is, we take estimated GDP numbers from several economists and organizations. We take survey from investors. So in financial and time series, in an economics discipline also, we can have cross sectional data. And in any discipline, in natural sciences also, we can have panel data. So this is very important to understand, that in whatever discipline you are there, what type of data out of these three you are going to use. And obviously, ma'am said that you have already done qualitative research, so there the data can also be quantitative or qualitative. Now, another very important thing, dear participants, is that what is the measurement scale of your data? So one is that what is the type of data? So whether it is time series, cross-sectional panel, depending upon number of units of study, and the time dimension, single point versus extended over time. But another aspect is at what scale they are measured. So I think many of you might be aware of this also. So there are 4 scales. 2 are considered non-metric or qualitative, while other 2 are considered metric or quantitative. So non-metric or qualitative scales, we have nominal and ordinal scale. So for example, nominal scale, we have categorical variables. Typically a word categorical variables is used in researches among, and is popular among academicians. So categorical variables are, or nominal scale variables are those which have, which in which there is no meaning of numbers assigned. We say it is non-metric. So for example, there is gender. Now, in any software, if you enter male, female, there cannot be any analysis, because no software will analyze alphabets or characters. You have to enter even variables like gender as numbers. So you enter, you give a coding. We do what is called a coding. We give male 1, female 2, or 0, 1, and so on. So we give coding. We assign numbers to categories. Now, these numbers, for example, if we give 1 to males and 2 to females, obviously it does not mean anything. 1 plus 1 is not 2. 1 plus 1, 1 into 1 is not, does not mean anything. 1 is not less than 2. 2 is not more than 1. So it has no meaning. So we say it is non-metric. We are only giving these numbers to label the categories, to identify the categories. And there is also no hierarchy in this. For example, males or females, nobody is superior, nobody is inferior. So whenever we have categorical variables in which there is no hierarchy and numbers are assigned only to identify the categories or give labels, We say it is nominal scale, the lowest form of measurement. And I will just tell you in the next slide that why understanding of the appropriate scale of measurement is immensely important for doing quantitative research and applying quantitative research techniques. Nominal scale, there are categories to which labels have been assigned and there is no hierarchy. Ordinal scale, again categorical, again numbers are assigned to categories, but there is a order. There is a order, there is a hierarchy. So for example, if we collect data on age of respondents, it can be anyone. It in medical research, it can be patients, it can be COVID infected patients. We are always, comparing in COVID times also, that what is the impact on senior citizens, what is the impact on middle aged people, are young people more immune than older people? So we collect data on age. So age, we collect data, we ask simply in terms of years. But for analysis purpose, if we club them into categories, so for example, we form three broad categories: less than 25 or 30 years, then 30 to 60 years, and 60 years and above. So young, middle aged, and senior citizens. For simplicity, just three categories. Now these are again categories: young, middle aged, and senior citizens, and we assign them numbers 1, 2, 3. But here it is clearly visible that though these numbers do not have any meaning, they cannot be multiplied or divided, but there is an order. So people in the first category, which is senior citizens, definitely are more aged than people are more in age, have more age compared to people in the second category, which is middle aged people, and further compared to the third category, which is youngsters. So ordinal scale is similar to nominal scale, but we have an order, we have a hierarchy. Similarly, countries are categorized as developed, developing, underdeveloped. So there is a hierarchy. Income levels, in understanding and doing all kind of social researches, we consider social economic backwardness of people. So we find out their income levels. So income levels we also can categorize. We do it upper class, middle class, lower class, and even in these we further classify lower middle, upper middle class, and so on. So here again it will be a categorical variable, non-metric variable, but there is some hierarchy, there is some order. While in metric variables, I will not go much into the distinction between interval and ratio, but I will give some examples. For example, on interval scale data, we can do additions and subtraction, but not multiplication and division. There is a technical thing, we cannot do multiplication and division on interval scale data because origin is not fixed. While for ratio scale data, absolute, we are in ratio scale, we are talking about absolute numbers. So absolute numbers exist on a number line ranging from minus infinity to plus infinity, zero being somewhere in middle. So if there is a middle, because the series is infinite, so we cannot say what are the ends. So, but ratio scale, absolute numbers exist on real number line. So we can multiply, we can divide. So ratio scale data is age, height, weight, income of the people, number of population size. All these are ratio scale data. Interval scale data, very good examples, though there is still some debate between statisticians and social science researchers. Statisticians say that scales that we use in behavioral and social studies are not exactly interval, while social science people keep on assuming it. But leaving aside that controversy, generally Likert scale items Likert scale items are considered interval scale, at least for behavioral researchers, social science researchers. So for example, you take opinion of people on a scale of 5-point Likert scale, from strongly agree to strongly disagree. 7-point Likert scale you can also have, strongly agree to strongly disagree. How we will have a 7-point Likert scale? Strongly agree, somewhat agree, agree, in strongly agree, agree, somewhat agree, neutral, somewhat disagree, disagree, and strongly disagree. So 5-point, 7-point Likert scale statements, or you can take a linear scale. Now, what is getting popularity in social sciences, I will also expose you to a data set which is used using the linear scale. So linear scale is simply 1 to 10. You ask people to rate on a scale from 1 to 10, 1 being the lowest and 10 being the highest. So, this bypasses problems regarding the data not being of adequate mathematical quality. So interval scale data is used a lot in taking preferences, in taking opinions of people, because these things are qualitative. So what is the way that you want to ask someone whether they like something or not, whether they like the advertisement, whether they like the product, whether they like the idea, what is the, or you want to rate few things, rate things like, say, uh, things which are subjective in nature, beauty, intelligence, IQ. So you need some scale. So it may be ordinal also, ranking. As we see, rankings are all ordinal data, but it can also be interval scale depending upon what is the underlying method and what is the underlying assumption regarding data points that are there on the scale. And ratio scale is absolute numbers. This is why I was telling all of this, because permissible statistics and permissible tests depend heavily on the scale of measurement. So binary is nothing. Binary is just having two categories: yes, no, male, female, alive, dead, and COVID positive or COVID negative, such thing. So binary is similar, can be a subset of nominal. Nominal with two categories is binary. So whatever can be done on binary or nominal data can be done on ordinal data. So you can see, for ordinal data, we say nominal plus something. Similarly, for interval data, we say ordinal plus something. And when you have ratio data, that is, you have absolute numbers which exist on real number line. So you can apply any technique developed or known to mankind. So I will be sharing the PPT. So I think, this was to just give you an overview. So permissible descriptive statistics and tests. Now, one important thing before we move ahead is that samples is the role of sample size. So we often guess why sample size is required or why we should have large samples. So please be assured, whether you call it a bias, we often call it in social sciences and in natural sciences also as a large sample bias. Because why is there a bias? Because statistical tests and techniques particularly regarding computation of test statistic value, or and ultimately leading to p values, are, if you see the formula in denominator, we have n. For example, in standard error, we have the in denominator n, small n, or n minus 1 or n minus 2, depending upon what we are doing. So small n represents sample size. So I'm not going into that technical formulas and details, but the idea is that if you have different sample sizes, your results may vary. So for example, we are looking to test all kinds of relationship, all kinds of impact in researches. Whenever we are talking about research, we are dealing with variables and we are trying to find their association or impact of something on something. So that impact, or that if relationship, if we call it effect, then large effects will also become insignificant, will not come out statistically significant if you have very small sample size. And even small effect can become significant, statistically significant, in large sample sizes. So one panacea, one solution for many statistical problems is to have a large sample size wherever possible, wherever feasible. And in all researches, particularly in behavioral and social sciences researches, less in natural science researches, we have what is called measurement error. So measurement error is that what we are trying to measure, we cannot measure it exactly. For example, if you want to measure opinion of people, if you want to measure intelligence of a person. So now, for example, we know that there are 8 or 9 types of intelligence, and earlier we used to only consider numeric intelligence. Now there can be that somebody is able to do things quickly, that is one type of intelligence, but somebody is able to do more intricate things, more complex things, but need time, that is another kind of intelligence. So and anyways, in all kinds of studies, so there are different social science researchers, for example, researchers that they in foreign countries, there are researchers on what are the reasons for people going for extramarital affair. Now if you ask people regarding extramarital affair, how honestly do you expect them to respond? So sometimes people do not respond, particularly in social science and behavioral researches. Sometimes people do not give honest feedback. Sometimes they do not understand the question. Sometimes the question itself or the options or the scale is misleading or confusing. So, whatever be the reason, we have measurement error. Unless, in fact, even in natural sciences, we have some degree of measurement error. For example, while measuring time or while measuring temperature and scientific things, also, we have some error, some very, very small error. Obviously, it is reducing as science and equipments are advancing. But in social science, it is heavy. Now, one solution to do it, one solution why for this is that to measure same thing, researchers ask 2 3 questions, at least 3 to 5 questions per construct. So whatever construct, whatever behavioral thing you want to study, so you want to study belief, you want to study spiritual orientation, you want to study environmental consciousness of consumers, you whatever you want to social phenomena, you want to see likeness or opinion of people. So you do not ask them in a single statement. You ask them 3 to 5 similar statements, and then take their average or summation, and then use that data for further analysis. So this is one way to bypass measurement error, and it also brings us to two very important things: validity and reliability. So validity is degree to which a measurement accurately represents what it is supposed to, and reliability is whether the measurements are true, and thus whether the observed value measures the true value and is error free. So one example of reliability, one way of inducing reliability is that we do, which is getting very popular in research, is longitudinal studies. So for example, if you are measuring any social phenomena, then take a opinion, you have taken surveys at a point of time, it is a cross sectional data. Do not limit your study. If you want to crack the best journals in social sciences nowadays, this is their expectation. Take the survey from preferably the same respondents again after few months, and this will validate your earlier findings, whether the results are holding consistent, whether the results and findings are consistent even after some time. So this is one way. And again, I am sure you are aware of reliability measures like Cronbach alpha and so on. So those things are also there, and there are different types of validity, face validity, etc. I am not going into that, so you can see that. One final argument that I will put is that whenever we are doing quantitative research, this will always happen that the results might differ a bit from previous studies as well as from our own work, or there may be some difference due to any reason. The primary thing that we can assign this to is spatio-temporal differences. Spatio differences meaning the same thing has been studied or measured in India versus same thing has been measured in another country. So there will be difference because of space or where you are conducting that study. And temporal meaning time differences. So in if you are asking Indian consumers their sentiment, so there are several, we are talking about economy and health, keeping them intact simultaneously. So you take consumer surveys and opinions 9 months ago in January, and you take them today. So there will be huge difference. So this, if you, even if the respondents are same and India is same, India geographically same, but this difference is occurring because of time. So temporal is time and spatio is place where you are conducting, or context within which you are conducting the study. So many discrepancies and differences from earlier studies and in quantitative research can be attributed to spatio, where and in what context you have done the study, and temporal, time dimension, at what point of time you have done the study. Spatio-temporal differences. This you should keep in mind. Now, quickly coming to quantitative research techniques. So, one very simple way is to do tabulation and cross tabulation. So one very simple thing is that you make a frequency table. So you start with saying that how many people belong to a particular category out of our total respondents, or how many people have said yes that they will buy a product, or they will subscribe to a say idea, or support an idea, or subscribe to an ideology, or anything, any social thing. So, for example, in USA, I was seeing the presidential and vice presidential debate. US elections are coming up. So, in America, there was a survey conducted that if a vaccine is available by the end of the year, how many Americans will actually take a COVID vaccine shot? And it was really surprising to both Democrat and Republican candidates that the survey revealed that only 50% of US citizens are trusting, and they are willing to take a COVID vaccine despite the large impact of COVID-19 on all aspects of life. So you tabulate the result. How many are willing to take the vaccine? If vaccine is there, how many are not willing to take the vaccine? So this frequency table, we all understand, it is very useful. Now, cross tabulation is helpful in the sense that, for example, we want to study two different things. So, for example, there is in gender studies and in women studies, which is there in literature also, which is there in all social science disciplines also. So there is always a always a comparison that are is there a glass ceiling for women, glass ceiling in corporate world or in political world. For example, India has been trying to pass women reservation bill for Lok Sabha and Rajya Sabha and state assemblies, but there is some statement by top leaders, but there is no ground support among political parties for such a bill, for such a reservation bill. So is there a reluctance, even though at panchayat level there is 50% reservation for women in India, but not at state and center level? They are asking for 33% reservation. So what is there a reluctance? Is there a discrimination against women in leadership positions, whether in political life or in business or in any other organization? So one very good thing that you can do is do a cross tabulation analysis. So have a row. So if I quickly show it in a Excel, so these are the ideas that you can pursue. So what I can do here in Excel is that if I have simply take two types of data, so I here take gender, we are officially to also consider the others category now in India. So gender, male, female, others, and here we take income, or we say position in management, and we say, for example, top management, middle management, or low management, or if we call it simply leadership role. So leadership role in all kinds of organizations, whether public, whether private, whether political, whether business, whether organizational, whether educational institution. For example, in another program we had a session on leadership, educational leadership, gender and educational leadership. Are women in there in leadership role in educational institutions? So these numbers can reveal a lot. So for example, in top management, out of top management or top leadership in any organization, what is the proportion of say males and what is the proportion of females? So for this kind of analysis, we have cross tabulation and we have chi-square technique. So chi-square technique can be used for this. Then we have ANOVA, I will tell you. So common inferential tests for comparing means. So we use t-test widely in this regard. So many of you might be confused that we also have normal distribution and z-test. So why do we use t-test? So t-test is used due to two reasons particularly. One, that in most cases population standard deviation is not known, so we have to define the entire population and we can almost never collect data of entire population. So population is not known, so obviously population standard deviation is also not known. And often the sample size is less than 30, so we use t-test. If it is more than 30, then t distribution automatically resembles normal distribution. So that is why in research, in quantitative research, you will find at very few places z test, but at most places you will find what is called t test. Now there are several t tests: one sample t test, independent sample t test, paired sample t test, and there is also one way ANOVA, which is not a t test but it is also used for comparing means. So I will try to do this through software, and I will then explain to you what is their uses and meaning. So I will be coming to that. And there are, parametric versus non-parametric research techniques. So parametric techniques basically make an assumption about probability distribution, because for hypothesis testing we will need some p-value probabilities. So what is the assumed distribution? So generally it is normal. In non-parametric there is no assumptions. So non-parametric techniques are also called assumption-free tests or assumption-free techniques. So you can just have a look at it. I will not be going into detail, but I will say that when assumptions of parametric tests are not met, we can use non-parametric tests. But generally, parametric tests are more robust, more powerful, and they are preferred whenever it is feasible. We should go for parametric tests. And finally, just to give an overview, finally, apart from these inferential tests, we can classify research techniques, quantitative research techniques on two bases. One is the dependence techniques and one is the interdependence techniques. So the independence techniques, we clearly assume that something is in what we say, in scientific method. So we have this from natural sciences, cause and effect. Science says that everything has a logical reason, everything has a cause. So cause and effect, dependent and independent variable. This is the cause and this is the effect. And that idea has been heavily borrowed and used from natural sciences into social sciences, as we know. And all the regression and other techniques that you can see here are based on causal relationship of and classifying variables as dependent or independent. While we also have interdependence techniques in which variables are there, but we are not classifying them as independent and dependent. So two very popular examples are factor analysis and correlation analysis. So in factor analysis and correlation analysis, we do not classify the available variables as dependent, independent. In factor analysis, we try to combine them into a larger construct. And in correlation, we simply test the association. We do not establish causality. So these are the broad two ways of classifying these techniques, and I will share some books if you are interested, and you can refer and read about these more from those sources. So final few things, while selecting a quantitative research technique, please keep in mind that what type of relationship you are taking, what is the type of data, and what is the scale of measurement of the variable. If you are fine with these things, then you are good to go with any quantitative research technique. One, whether it is dependence or independence, that is, you want to establish causality or you simply want to measure check for association, or you want to specifically establish causal relationship. Second, what is the scale of measurement of these variables? And what are the types of data, time series, cross sectional, and panel? Then if you understand these things, then you are good to go. Please understand, dear participants, that participants always often miss the point. I have in my 7 years dealt with 100 plus research scholars. I do not have any record or list. There is huge confusion. Please understand that softwares for analysis do not understand that you are coming from biology, physics, chemistry, mathematics, statistics, or from political science, sociology, philosophy, or psychology. They do not understand this. For software, it is only whether the variable is, what is the scale of measurement of the variable, and what is the type of data, and what type of relationship you want to establish. So for softwares, it is only numbers, and what is their scale, and what is type, and what you want to do. So please, these things you need to understand for choosing appropriate techniques. And the basic procedure is establish significance, know your data, look at your errors, and validate your results. Final thoughts, I will come towards the end. Now, I was given inputs that I should talk about this through SPSS a little. So SPSS, many of you might be using it or familiar with, because SPSS is popular in social sciences. So SPSS basically stands for Statistical Package for Social Sciences. The first version was announced way back in 1968, before any other popular softwares were produced. SPSS was initially run by SPSS Inc., but it was later acquired by IBM. So thereafter, it is known as IBM SPSS Statistics. The latest version is 25th version of SPSS, which was launched in 2018. I think SPSS is a licensed. SPSS is a licensed software. IBM is not into doing, providing free software. SPSS in free as a free software. So you should keep in mind that you have to use a licensed version. Now, this licensed version maybe is available at your parent institution, whether you are a researcher or a teacher, or you can also buy it at your own, though it is costly for one individual person. Maybe you can go do it in group, or you can look to also use, if you want, if you have temporary users, sometimes people have to use it only for once or twice, then you can also consider using the trial version. But I think the validity is only 14 days, and they register your system number, so you cannot use a trial version on the same system again and again. But SPSS is very popular in for statistical analysis in social sciences, as well as in even in some natural science disciplines. It is an integrated family. Quickly understanding the data increases the analytical power and flexibility with choice of methods, high accuracy, and the results are very presentation ready, and communication for can be easily copied directly in your research paper or PPT or whatever project you are doing. So that is why SPSS is popular. And one very reason for popularity of SPSS is its graphical user interface. For example, if even if some of you are not familiar with SPSS, you can get started in few minutes. But at this point, I would like to tell you that you should also seriously consider using open source softwares like Excel also for some part of analysis. I will just be showing you that to you. Or there is softwares like R and Python, which can be used for all kinds of analysis. And uh, R and Python are very open source and popular. And R and Python, there is a slight learning curve. See, honestly speaking, I am not a computer science person, I'm not a statistics person, and few years ago I would not have also imagined using or learning R or Python, but I have done that. So R and Python is also, once you learn, initial learning curve may be slightly steeper than SPSS because it is not graphical user interface based, it is programming based. But then you will have rich benefit. For example, those softwares are open source, including Excel. If you have a legitimate Microsoft license, they are open to free source, and they have a large community of resources to help. And also you can copy paste and replicate the results, same analysis over and over. So there are many advantages. But for now we will be seeing these things, seeing some of the things through Excel and SPSS. So to begin with, I will first show the things with SPSS, and then I will also show how those things, what is the option available in Excel. And so let me just open my SPSS. So it is slightly heavy software, so just couple of minutes I think to load. So meanwhile, I also got the opportunity while SPSS is loading to go on YouTube and see your comments. So thank you participants for your positive response. But SPSS is there, so let me get back to SPSS. So this is the SPSS interface. I think our dear organizing team has also shared with you a PPT, introductory PPT for SPSS. But I will also be, following that up. So if you will, be able to see things from this. And don't worry if you feel that I'm going very fast, don't bother. This is the video will be available to you as is for other sessions. So there is a advantage of technology. You can pause it, you can rewind it, you can even reduce the playback speed. So if I'm saying very fast because I have to cover very a lot of things in a lot of small time, they can easily replay and decrease the playback speed and see what I am doing or hearing slowly. So you will be able to catch up, so don't bother about that, I would say. Now, dear participants, SPSS is having two interfaces. So one is the data editor. You can see here that it is named IBM SPSS data editor. I'm using the 25th version. So, but version wise, in the basic features, there is very little differences across versions. So don't bother. If you have SPSS, you will be able to use most of these things yourself also, now or later, whenever you need it. Now, in this SPSS, we have a data editor. In data editor, you can see we have a variable view and we have a data view. So variable view is basically like a command center variable with with the same name, which you have given here. And two, three things, there are 7, 8 things here. Two, three things are very important to keep in mind, that check the type of variable. So numeric or string are the popular choices, but I will make it very simple to for you. If your variable includes only numbers, if your variable includes only numbers, then you should always ensure that the type is numeric. If your variable includes only numbers, ensure that the type is numeric. If it includes anything else than numbers, particularly alphabets or combination alphanumeric that we call alphabets and numbers, then use string. Or they, there are some other things also like date and other things. But normally, if it is variable in which there are values of something, then use it as numeric. So for example, whatever you are measuring, so for example, if you are measuring interest rate in India, 2 days ago we had RBI's monetary policy announcement. If you are using interest rate data for any research, so in, the variable should be interest rate in percentage, and within that variable there should be, in the data set actually there should be only numbers. And you can see, you can change the decimal places also. You can make the decimal places 0, you can make it 1, you can make it 2, you can enter the number, or you can also increase decrease from this up and down arrows. Width and column size are similar, are having common role. Width is the number of letters or characters that you can that you can enter for a particular variable, and columns is what will be visible to you. Then label is associated with name, in a sense that name in SPSS are not allowed to have any space, so you will have to use underscore, or you will have to use uh, continuous without, say, with like this you can say full name. So caps lock for the new word, or underscore, because spaces is not allowed. And in some versions there is also character limit for variables. So keep the name as short, but you can write the entire description of that variable in label. Then values. So for categorical variables, I will just be showing you a data set, and I will be showing you this values option. Missing, you can specify for a particular variable. If there is, by default SPSS assumes that there are no missing values, especially because you are also, if you are working on, say, Google Forms nowadays, it is very commonly used for all kind of researches. So if you are using Google Forms, then you can obviously specify, make a question mandatory, so there is reduction in possibility of missing values. But if you have a missing value, you can use this discrete missing value option and say put 9 here, and tell SPSS that in the variable full name, wherever you find 9, this 9 denotes a missing value. Columns I have discussed. Alignment is by default, SPSS gives numeric variables the right alignment, and I think string variables the left alignment, but you can easily change it. Measurement is very important, dear participants. So you are familiar with this now, nominal, ordinal, and the other two, the metric ones, that's interval and ratio. Both of them are jointly clubbed in scale as measure for SPSS. They are there in scale. So this is the thing, and you can, for example, if I am using name, so I should be using string instead of numeric, because, and you can, because it will, this we have to enter alphabets, we cannot enter numbers. And you can write name here. So you can see I am not able to type beyond M, because 1 2 3 4 5 6 7 8, the character limit, the width is 8 here, so I cannot enter more than 8. So this is the role of width. And columns is that portion of width which will be visible. So we often keep column size small if we have large data sets, so as to be able to see several things simultaneously in the same screen. And you can easily save this file, so you can simply click here on the save button, and you can choose your location, you can give a name, and like we have the extensions, like we have the identification extensions for all types of software. So for SPSS, we have actually two types of extensions. So SAV is for input data and SPV is for SPSS output. SAV is for input file, SPV is for output file. So whenever you find any uh, SAV file, then you should understand that it is the SPSS data file. And if there is SPV file, then it is a SPSS output file. Output file I will be showing you in a short while. When we do something, you will see the output window also. There are several other things you can, go through the PPT that has also been given, and you can also see some more information and videos on this. If you want, I will also suggest a book for this. Now, while in how to get a data set, this is the data set, for example, which I am creating. I can create name, and I can, create, say, for example, age, and I can give it a number. I can put decimals as 0, and I can specify the scale as if I am collecting an age in years, then I can write here also age in years, then it is absolute number. So I will give it a scale measurement, and decimals are 0 and numeric, and I can write, you can see age is here, and I can write in the variables column, and I can create a data set. So like you create data set in Excel or any other software, you can also do it in SPSS. So this is one way of having your data in SPSS. Another way is to import the data set. Import the data set from other softwares, and particularly from Excel. So what happens is that you're downloading the two main sources of data are secondary and primary data. So secondary data you have downloaded from some website, and primary data you have created, say, Google form, or you have typed in an Excel sheet. So you have the data in primary data. Whether you use Google form, then you can go and download the spreadsheet responses, so you will have it there, or you create uh, your own data in Excel, or you download some data set from any secondary data source, and that is also downloaded in terms of Excel file or CSV file, comma separated values file. CSV file can be opened using Excel. So when we have those kind of data sets with us, then we can go to file, import data. So you can see there are several options, and I'm not telling you about these options, because if you are using that, you can understand what is the option. You can identify the associated software. So I was, told that we can cover this also. So I will be covering importing data from Excel. So if I quickly go to the folder. So just a minute. So if I open this data set, so for example, I have gone to the location of today's session, and I have identified the Excel file. Now what happens is that one common error that people make is that in the files of type, you have chosen something else. So for example, you have chosen the default option is SPSS or Stata or any other extension. So you will not see this file here. So please ensure that, for example, if you're trying to open an Excel file, then the files of type you have selected Excel. Or if you have any confusion, just go for all files. So if we go for all files, then you will find everything that is there in this folder. Or since we have already chosen Excel, so it is showing only Excel files. And if I open it, I just have to click open. This is the preview, and you can see read variable names from the first row of data. This is not very relevant, and you can click on OK, and you can see, you will be able to see the data set. This is the data of HPAT regarding their customers. and you can go to variable view and you can appropriately choose the scale of measurement. So this is how you import data in SPSS. Now I will be working on a more general data. I will not be working on a business data. I will be working on a data which all of us can relate to and understand, which is the data regarding students, because people in this program are from all disciplines. But I will also be telling you about the application of tests from all disciplines. So if I can share the screen. Okay. So let me open the data set and then I will be sharing the screen. So what data set I'm showing to you now is a data of students in an American school, and the data set is called grades data. So let me share the screen. So we all understand grades. So these, last name and first name of students, gender, ethnicity. Now, for example, gender must be a categorical variable. So we need to know what these numbers mean in gender. So if you go to variable view, as I was telling you, if you go to the values option, there you can see that this is the coding provided for a categorical variable like gender. I said to you earlier also, we have to provide coding for categorical variables. And please keep in mind a very, very important thing, that even categorical variables have to be entered as numbers. So you have to enter gender, for example, also as numbers, 1 or 2. You do not have to enter gender as female, male. SPSS will not work on that. You have to enter it as a number, and then you have to run this. So this is the gender. It's some similarly we have ethnicity, and in America we have these 5 ethnic communities, mainly Native Americans, Asians, blacks, whites, and Hispanic Americans. And these are the data. Some of the variables are on scale. So for example, quiz scores, we all do quizzes and tests in our subject. So quiz scores, quiz 1 to 5, the data is of on a scale of 10, then final exam and the total and percentage and grade. So and for example, the missing value, use of missing value. So for example, Anne Osborne has not shared his or has declined to share his or her gender. So this can happen if, for example, you have not provided the other option or prefer not say option. So Anne Osborne has not told anything about their gender. So this is a missing value. So we have given 9 here, because we have given 9 because the maximum values that can be here is 1 or 2. So 9 will be an outside value. So outside value, outside the range. So for example, if you're talking about percentages, then it can be up to 100. So you have to take 999, something which is outside the range, odd person out. You can, software can easily identify. So how we have dealt with this, we have written here, this must be blank. So we have written here 9, and in the variable, in gender option, you can see here in missing option, we have specified discrete missing value as 9. So wherever SPSS finds a 9 in gender series, like for Osborne, they will understand that this is a missing data. Now let me quickly do the tests and do the so I promise that I will be covering those few tests and their inference from SPSS. So I was talking about these tests. So these tests, let us quickly take an overview and then we will do it and interpret it. So one sample t-test is used for comparing the average value of a series to a benchmark. So please understand its wide uses. So for example, you have, if a very common scale that is used in political science and also for checking social orientation of people, is that they are they use a scale 1 to 10. wherein one meaning that you are oriented towards left ideologies and you are, in favor of left thoughts and ideas, and 10 meaning you are in favor of right wing ideologies. So 1 to 10, this is a very common scale in political science. And they take survey and responses from people, or that on a scale of 1 to 10, please rate your political orientation, 1 being extreme left and 10 being extreme right. So where do you lie? So many people will lie in the middle and long towards the left and towards the right and so on. But after you have collected data, say from 200 people or 1000 people, now you need to do, now you can compute an average, but this average will only be for the limited data set, 1000, 2000, whatever is your sample size. So you can compute a descriptive statistic and you will get an average value, but that will be limited only to that sample data set. In research, we want to use sample data to generalize about the entire population. That is our purpose, to generalize for the entire population. So here we have to do statistical test, hypothesis testing through one sample t-test. Similarly, you are asking whether a customer has liked your product or not. Again, you are asking on a scale of 1 to 10 or on a scale of 1 to 5, how tech savvy, how much, there are several studies and researches going on during COVID-19, even in educational community amongst us. So how well have the students or teachers adopted to online teaching platforms? On a scale of 1 to 5, strongly disagree, strongly agree, 1 to 7, strongly disagree, strongly agree. So you can set a benchmark value and test the average of that series against that value. So let me show you with how this is done in SPSS. So for example, we have to go to analyze, compare means. So now this is very intuitive. This is very basic. So if you have to do some analysis, where we will go? We will obviously go in one tab which is analyze, and then we have to compare means. So obviously the next is comparing means, and then we can find one sample t-test. And here if we say want to check that what is the percent score, or yes, so let's say percent score and test value, we want to put 75. That is the, because I know that this data is slightly on the higher side, or let's remove this. Let's enter quizzes 1 to 5. So you can see what I'm doing. I'm clicking on quiz 1, shift and down arrow, and I can enter all the 5 simultaneously. This is the list of all variables, and this is the variables that you are going to use for your particular test. And anything that you find problematic in SPSS, you can, this is one feature of SPSS which is not available in many other software packages except open source packages, R or Python. You have the help community, but other softwares this is not available, is the help button along with every technique or method that is being used. So you can simply click on help, and this will give you a description of all the options that are available for one sample t-test. Now quizzes 1 to 5, and this is, I know this is on a scale of 1 to 10. We had the scoring was out of 10. So I say want to know how many students have scored more than 6, or not more than 6, whether the average score of students in these quizzes, is it different from 6, is it more than 6, is it less than 6, is it equal, is it not different from 6? What we want to see is that whether the average value of these variables, like average political orientation, average for example, we can also do this in proportion. So for example, in different states you have different proportion of uh, people infected from COVID-19. You have the data for 30 states of percentage of people having antibodies in zero surveys, or the different parts of Delhi, and you have the data. And you can test what is the average percentage across the country of infection or having antibodies, COVID antibodies. So whatever, or in marketing, for example, you all must be using some telecom service provider, Airtel, Jio, Vodafone Idea. So what is the average, uh, you know revenue per user. So some may be paying 200 rupees for telecom services, some may be paying 500, but what is the average? So we can test it against our benchmark. So we can say that let's see if it is equal to 6, or in statistically we say not different from 6, or greater than 6, or less than 6. This test value you have to specify based on your objective. So if I just click on OK and leave everything same, then I will have to, share another screen, which is the output viewer. So here you can see in the output window that we get automatically, we get the descriptive statistics. There are 105 students. This is mean, this is standard deviation, you can understand. And the inference part, how to interpret this test. So you see one sample test value is 6. Test value is 6, and we have the t statistic, we have the degree of freedom, we have its significance in terms of p-value, we have mean difference. Mean difference is actual minus test value. So you can see 7.47 minus 6 will be roughly equal to this 7.981 minus 6. Mean difference is difference between actual average minus the test value that we have provided, and we have 95% confidence interval. So not to complicate things, what you need to do, if I say in a very layman terms, in a very simple terms, we have statistics faculty members with us in this program. So I will take their apology. I will seek apology from them. But if I put it very bluntly and very simply in a layman terms, you only need to know the null hypothesis and the p-value for interpreting any test. So the null hypothesis is that the average value of the series is equal to 6. And just see what is the probability, significance. If you do not understand other things, just do this. So test null hypothesis is for all one sample test, whatever data you are dealing, scientific data, medical research data, social science data, any data, test value is equal to this. Average score of the variable, average value is equal to this 6, which we have provided here. So you have to remember what is the null hypothesis and just see the probabilities. And these probabilities or p-values, there is a formal definition. Again, I'm not going into that formal definition. It will take few minutes to explain that. I'm simply saying that p-value is the probability in favor or support of null hypothesis. आप इसे लिखिएगा मत कहीं पर, समझने के लिए keep it this in mind, that p-value is the probability in favor of null hypothesis. So significance or p-value is in favor of null hypothesis. So you can see here, and in fact, it is also by definition also the probability that null hypothesis, the test statistic will take a value equal to or larger than the criterion value if the null hypothesis was true. But to remove all the jargon in between technical stuff, it is simply probability if null hypothesis was true. So you can see here, and the normal benchmarks are 5 and 10%, because we want at least 5% chance for null hypothesis to be true. So we do not reject it. If it is less than 5%, we say that the probability of null hypothesis is very, very less. So we have to reject it. So you can see that significance value or p-value is very, very less here. So the null hypothesis, the probability in favor of null hypothesis out of 1 or 100% is very, very less. It is not even 1%. So we can strongly reject the null hypothesis in all these cases. That means for all the 5 quiz scores, the test value, the average test score is significantly higher than 6. For all quizzes, the average test score is significantly higher than 6. Because higher than 6, we know, because the average value is very clearly visible, is greater than 6. You can also see that the mean difference is positive. So we say it is higher than 6. Now, if I quickly, you can use this option. This is for recently used. If I quickly, put say 9 here, and I rerun the test, you can see that for some quizzes, now the mean difference will become negative, because the formula remains same, 7.47. Now minus, we are deducting 9. So this value is negative. And again, we have significant results. Null hypothesis is getting rejected because the significance or p-value probability in its favor is very, very less. So null hypothesis is rejected. So we can say that the average quiz scores are significantly less than 9. Less than because mean difference is negative. You can also see that mean score of all quizzes are less than 9. Now, dear participants, another very important test which we very widely use, and I will tell you why, is paired sample t-test. Now, before I show you paired sample t-test, please understand the widespread uses of paired sample t-test. So whenever you want to measure impact of some intervention, so in scientific interventions, so for example, there is huge amount of research that is going on, as you know, in vaccine developments. So what they have done is that they have segregated, for example, they have measured the performance before giving a particular drug or treatment, and they have measured performance after giving, because several drugs, as you are aware, is being used to check whether it can help COVID-19 patients, and it's in its treatment. Several of the available drugs, because new vaccine development is taking time, it is a rigorous process. So several drugs were tested. So whether any of those existing drugs can have a positive impact on patients. Now, in economics, you have seen that there is implementation of GST. So, what has been the impact on government tax revenues after implementation of GST? You have seen that there was a demonetization that was done in 2016, I think. So, what is the impact of demonetization on cash levels in the economy? One purpose of demonetization was to reduce the cash uses. So are people using less cash after demonetization? That is one thing. So what you will do, you will have before data and you will have after data. So cash prevalence, cash circulating in economy few months before demonetization and few months after demonetization. Government tax revenue after implementation of GST, indirect tax revenue after implementation of GST and before implementation of GST. We have training programs for employees and health workers and employees in every sector. So for example, you may be giving feedback and we ask questions like that. What was your knowledge about the topics before the session and after the session? So we have two sets of data: knowledge before, knowledge after. So this is paired sample t-test. Paired, or this is also called dependent sample t-test, because the underlying population, underlying sample is same. For example, also in, say, military training or any such training programs. For example, in public sector banks, we give soft skills training because sarkari babus are considered to be behaving very roughly with people. They do not have soft skills, so we give them soft skills. And then we take the customer responses, visitors responses, that has the behavior of PSU bank employees improved while dealing with customers after this training program, and if it is effective, we will apply it on others also. So in wide range of things, in a politics, you are considering that what is the impact, whether a person should be labeled as a star campaigner or not. So you take the perception of people in regarding the political party before, on a say 1 to 5 or 1 to 10 scale, how likely they are likely to vote for that political party. Then you collect the data, cross sectional data, 100 people you have taken the responses, how likely they are to vote for that political party on a 1 to 5 or 1 to 10 scale. And then you bring in a star campaigner. You bring in a Bollywood celebrity, or you bring in a famous political person or former minister or something. And then after their rally or speech, you again take the opinion of the people in the same locality, and preferably, and in fact actually, of the same people you should take. The underlying sample should be same, so you have to take feedback from same 100 people after their speech, and you can see. So before and after situations is very common and very important. So for example, we have same set of students. So what I want to check is that has the performance of students improved? You can have many more pairs here. Has the performance of students improved after the first quiz? So because after one quiz, students know what type of questions will be asked, what is the difficulty level, what is the mindset of teacher, what things to prepare for exams. So same set of students have given these two quizzes, quiz 1 and quiz 2. So now we want to check whether the average value has improved in quiz 2 versus quiz 1. Or we had also conducted some in education. We have to conduct mentor mentee programs as part of NAC requirement. We also have to provide remedial and support classes for weaker students. So after quiz 1, some performed poorly, so we provided support classes. Now what is the data, what is the evidence that the performance improved? So you can collect the quiz 1 scores, and then you had the remedial class, and then you take another quiz and see the difference. So if I click OK, I have just entered quiz 2 and quiz 1. There is no particular order, but it will always be variable 1 minus variable 2. So quiz 2 minus quiz 1. And if I click here, you can see again the descriptive statistics. Quiz 2 score is 7.98 and quiz 1 is 7.47. So yes, your remedial classes or mentor mentee or whatever intervention you did has a statistical backing, has a proof that yes, it was effective, but this is only descriptive statistics. We should definitely conduct the inference test like paired sample test also. So the null hypothesis in this case is there is no difference. So the average score of students in quiz 2 is same as average score of students in quiz 1. Or we can say that average score in quiz 2 minus average score in quiz 1 will be 0. The mean difference will be 0. So you can see that the mean difference value is 0.514, which is positive, obviously, because we are doing quiz 2 minus 1, quiz 1, and quiz 2 is obviously higher. So the difference is positive. And again, come to this significance value. Null hypothesis, come directly to this significance value. And you can see this value is very, very less, 0.005. 0.005 means only 0.5%. So even going by a strict criteria, we take 1% significance level. So 1% significance level will also mean 0.01. 1% is 1 by 100 or 0.01, but this is 0.005. So this is strongly rejected, and this is rejected even at 1% level of significance. That means the null hypothesis, which said that there is no difference between quiz 2 and quiz 1, that null hypothesis is rejected. There is a significant difference between average score of students in quiz 2 and quiz 1. And which one is higher? You can again see from the mean difference. Quiz 2 minus quiz 1 is positive, or you can see from these values here. You can clearly see. So we can conclude that the average score of students in quiz 2 is significantly higher than average score of students in quiz 1. Similarly, there has been significant increase in revenue or favorable opinion or liking or preference, or significant improvement in health uh, after a medical intervention. So for same 100 people, you before giving a treatment and after giving the treatment, after for example, plasma therapy has been in discussion so much. So before the condition on normal medication and after giving plasma therapy, what has been the improvement? So before and after, all these situations you can use it. And it is already 12. I have to wind up quickly. I have been given time till 12:05. So let me just do one more major test, which is independent sample t-test. So again, independent sample t-test is again used for comparison, but now we will be comparing across different categories. So now, unlike the paired sample wherein the underlying population was same, underlying respondents were same, but they were in two different situations. Here, we are talking about sets of two different sets of people or two different set of respondents. For example, I recently came across a study. So there is one way of doing research in, for example, COVID treatment that is going on, is that for COVID positive patients, for the first 3 or 5 days, you do not give plasma therapy, and after plasma therapy you take their measurements for same patients after for next 3 to 5 days. So 3 to 5 days before giving plasma therapy, you take their vitals, and 3 to 5 days after taking plasma therapy, you take their vitals. Other way around, which I saw, was that one group of patients was not given plasma therapy, and one group of patients was given plasma therapy. One group of patients was not given hydroxychloroquine. You must have remembered hydroxychloroquine was very famous in the initial days. And another group of patients was not given hydroxychloroquine. So, what is the difference in their health? So, independent sample t-test again. So, for example, online shopping, male, female, political orientation, or male female, which who are more tech savvy, male female, or what is the pattern, say North Indian, South Indian, or again comparison across any groups of ethnic community, any socio-economic profile, anything. If you want to compare, you have to use same thing, which is independent sample t-test. So for example, here I will like to use percentage as the dependent variable, and for example let us see whether it differs across gender. So when you enter gender, it will give a question mark asking it to define groups. So you can SPSS is asking you, how do I know which group does one belong to? So group 1 is 1 and group 2 is 2. So we have, because we have given 1 and 2 is the numeric coding which we have given to the two groups. So we say that one group is labeled by 1 and other group is labeled by 2. We click on continue and we click on OK, and we get SPSS results for independent sample t-test. Levine's test for equality, you can percentage is our dependent variable. You can also see there are 63 females in our 105 data set and 41 male students, and the average score of female students is 81.54, and average percentage score of male students is 78.46. So there is slightly higher score of females, but we have to again see, to generalize, to be able to generalize, we have to see whether it is statistically significant or not, and what's the probability of null hypothesis. So null hypothesis here would say that there is no difference. So there are two results for t-test, because if Levine's test is met or not met. But if we keep that aside for a while, you can see the t-test for equality of means. The results are almost similar, and t-test is robust in both cases. So you should not worry about that. And mean difference you can see is same. 81.54 minus 78.46 is roughly 3.076. Significance value you can see now is more than 5%. Even if we take a lenient criteria of 10%, even then the significance is very high. So we cannot reject the null hypothesis, and hence there is no difference in average percentage score of males and females. So dear participants, this is what I wanted to do. And one final thing before I hand over to Bhavya ma'am and organizing team is that I wanted to show you one thing, that let me just open one Excel file, that you can do these things in Excel also. So just 1 minute, what you have to do is, so yes, I have opened my Excel file. So for example, this is some data. Now, how do you, get the tools for analysis? So for example, first, let me show you what tools I have. This is the Excel file you are all familiar with. I click on data, and you can see I have a option of data analysis. Data analysis here. And in data if I click on data analysis, you can see I have a lot of things: ANOVA, covariance, correlation, descriptive statistics, histogram, moving average, t-test, paired and one sample which we did, regression and random number generation, rank and percentile. All of this is here. How where it is data and data analysis, but this is not normally available by default in your Excel. How do you get it? So you have to go to file and you have to go to options, file, options, and add-ins, file, option, add-ins, and you can search and install what I have already installed, which is analysis tool pack. If you, this is an Excel add-in. If you install this analysis tool pack, this is by Microsoft only. I am not sure, but I think that this will work only, or this is freely available only for licensed versions of Microsoft. I had a licensed version. I got it with the laptop, so I think it works only on the licensed version. That is, add-in is available on the licensed version. So you can install this analysis tool pack add-in, and you will be able to use common things: descriptives, graphs, t-test, ANOVA, correlation, regression. Up to this you can do on Excel also. So that's it from my side. uh, thank you very much for this opportunity. I know it was a little hurried up and jumbled up, but I hope it is useful. Over to you, Bhavya ma'am.
Thank you, Dr. Arnav. And it was not hurried and not jumbled up. I would rather say it was quite crisp and precise. You actually addressed all the queries of the participants. And I think it was a wonderful, wonderful session that you took. And it has, I think,
Ma'am, you are not audible. Is it me only, or?
I am not audible. Vipin, sir, if you can confirm.
I'm audible. You are audible,
You are
ma'am.
audible.
Okay.
Okay, sorry ma'am. I had
Arnav,
uh,
sir, okay. Are you able to hear me?
yes ma'am, sorry, I had put
Okay, so
yeah.
I was actually just appreciating your presentation. It was actually perfect and very well done. I am really impressed, and so are the participants. You can see the comments on the YouTube live link. There are a few questions that we would like to take up. From Velumani ji, could you please explain validity and reliability with an example?
Okay. So actually, there are four types of validity. One is face validity. That is, for example, whether your instrument which you are using in social science researchers, for example, you want to measure trust of people in, say, leadership, whether organizational leadership or, say, political leadership, or you want to say, as we said, COVID vaccine, the trust of people in COVID vaccine. So you have to make a questionnaire. Now, it is very delicate thing, as you would understand. What is the language of statements? How many statements are there? And is it really measuring what is it is supposed to measure? That is, will it really convey to us in terms of results? When we get the data, will we really be able to know the trust, whether it is there or not there, regarding COVID vaccine? So this has to be validated from, say, subject experts, and also we use our academic professors for this regard. Then there is, for example, another validity, which is construct or convergent and discriminant validity. So in a questionnaire or social science research, two constructs within a construct, so I said to you that for establishing, due to avoid measurement error, we often have multiple statements for the same construct. So for trust, we will be having 3 to 5 statements. Now, obviously, since all these 3 to 5 statements are for measuring trust, so they should be internally consistent with each other. They should be conveying the same thing. They should be measuring the same thing. So this can be checked statistically through construct validity. And one other validity is discriminant validity. So uh, two different constructs, if we are saying that trust is different from, say, actual uses or something like that. So these two things should be different. So there should be difference or divergence or discrimination between these two concepts. They should not be overlapping in an ideally designed questionnaire and an ideal study. And another validity, I think it is, I'm not, maybe I'm missing the name, maybe it is called structural validity or something. It is basically about whatever is your theoretical hypotheses which we framed, are they being able to, are they being validated by our data or not? So whether our initial hypotheses are being confirmed by our data. And finally, reliability, again, reliability is whether our results are reliable or not. So one way of measuring reliability is, as I said, repeat studies or internal consistency. So we use Cronbach alpha in that regard. Yes, ma'am.
Thank you, sir. Another question from Hari Kumar, sir. Explain the new trends in quantitative research related to political science.
So, sir, I am not actually from political science discipline, but I can tell you where you can get similar idea. For example, I am in finance and investment, as Bhavya ma'am told earlier. But what I found, what I did was that I applied neural networks for my PhD, which is from originating from biology and applications in computer science. I applied catastrophe theory, which is again originating from physics and mathematics. So similarly in political science, you should attend these kind of FTPs, look into best publications and journals, and look for different approaches. I cannot say specifically for political science, but the general idea is that you look in premier work that is coming up, cutting edge research, top journals in your field, and see what different methodologies they are using. And at this point, I would like to say that don't only look for quantitative methodologies, though I am taking a session and I am myself a very big user and fan of quantitative techniques. But I would tell you that if, especially in social science disciplines, for example, if you want to go deeper, you may need to use qualitative research techniques. It has been already covered. There are several techniques like grounded theory and all. In political science and social science disciplines, we have several techniques like structural equation modeling, mediation and moderation analysis. Then we have hierarchical regression. We have categorical regression models like logistic regression. We have multinomial probit and logit models. So it will depend. Better is that look, don't chase after the technique, look into topic and look into publication, and look as to what is the superior methodology or the newer technique, and from there on you derive it, then you will be able to use it.
Right, sir. A question from Neha Saini. Uh, she basically wants to know about purposive sampling method and mixed model. Is it possible to take purposive sampling method for mixed method approach?
uh, I'm not sure about purposive sampling, but mixed methods research, I am assuming, Neha, that you are asking regarding combination of qualitative and quantitative techniques. That is what I am assuming, and that is what I am basing my answer on. So purposive sampling, obviously we can use, but I think I'm not an expert on this sampling and research design part, because I have primarily been working on secondary data. But I think purposive sampling can be used and there is no problem. And regarding mixed method research, I would tell you that what is the trend recently that I have seen is that, especially in social science disciplines, people take both subjective, both qualitative data, and on which they use qualitative research techniques like grounded theory or phenomenology or such things, or case study approach, and then they substantiate those results with quantitative questionnaire based survey research, or vice versa also. First you base your ideas in quantitative research and then substantiate it with qualitative research to complete the picture. For example, if you, in mixed methods research, if you come across some findings for quantitative data, so based on quantitative data analysis you come at some findings that this is causing something or this is impacting something, But obviously, quantitative research cannot give you reasons or what is the underlying social psychology or underlying mindset behind those results. That you can follow up and build upon using qualitative research techniques. So mixed method is very, very popular and it is advisable to use. And I'm glad that in this FTP also both the things are being covered. And also, I would like to tell that purposive sampling and other type sampling techniques you can explore further. I'm not an expert on this, but my feeling and understanding is that it can be applied.
Okay, sir. If participants have any more queries, you can post in the chat box. Question from Renu ji. Please tell about when we can apply ANOVA.
Yes, so ANOVA actually has many uses. So ANOVA, for example, is also there for ANOVA is also there in regression. I don't know what is your statistical level of knowledge, but one common uses of ANOVA is obviously in regression. In if you have seen the regression output, it breaks up the variance. In regression output, you can see ANOVA table in which there is F statistic and significant ANOVA F test in which we break up the total variance of dependent variable as explained by the regression and residual. So there is one common uses of ANOVA. Another very common uses of ANOVA is for comparison across categories. So we did independent sample t-test, but the limitation of independent sample t-test is that we can use a categorical variable only with only two categories for independent sample t-test, like we use for gender male female. Whenever we have more than two categories, and we can have many situations in which we have more than two categories. So for example, there would be some patients who was one was given normal treatment, another was given plasma therapy, other people were taken some other existing drugs, and in banking sector, for example, NPA problem, default on loans, non-performing assets. So we have public sector, private sector, and foreign banks. There are three main banks, types of banks in India: public, private, foreign. So this becomes three categories. So whenever we have more than two categories, then so for example, even in there are gender studies and other disciplines in literature, and there are issues or just studies on sexual orientation, so straight and LGBTQ, and there is bisexual. So there can be many situations if you visualize in that way, that there we can have more than two categories. So whenever there is more than two categories, you will have to necessarily use one-way ANOVA. And there are advanced versions of ANOVA like MANOVA, which and ANCOVA, in which you can also combine two categorical variables for testing their impact on a dependent variable, or you can combine a categorical variable with a scale variable and check the impact. So these are some of the common uses of ANOVA.
Thank you, Arnav sir. I think we have explored several dimensions. Quantitative research ultimately has lots of things to talk about, and it's very difficult to put most of that in 1.5 hours. But I think you've done quite good justice. And most importantly, you have tried to focus on several different disciplines as well. So we have tried to cater to all audience. But of course, this is something that will take time. As and as you start exploring different techniques, you will actually be able to decide one that will best suit your research problem. Sir, there are many people who are asking for your email ID. So if you can share that right now as well, and we'll also share it.
Sure, ma'am. Sure, ma'am. So, uh, just a second. So, participants, here is the email ID, arnavkumardsc@gmail.com.
Thank you, sir. Thanks a lot for your time. It was a really fruitful session. We got to know so much. And of course, then when you talked about SPSS and Excel, we actually could understand the real picture. I mean, how we can implement those things. And it is so easy. You just have to, click a button and then you can apply all those tests, work with data. It's really nice. So thank you, Arnav sir, for everything. I hope you also had a nice experience.
Yes, ma'am, it was a wonderful session and thank you for the opportunity to organizing team. And it was good to interact with too. And sometimes we are in T20 mode, in test match mode. So it is also a good experience to do these kind of things in this manner. It was very satisfying. Thank you, ma'am.
Our pleasure, sir. Our pleasure. Even participants are giving very good feedback. They are all happy. So thanks a lot, sir. We'll be stopping for today. And to the participants, there is an announcement. We have extended the time for the previous assignments and quizzes. You will have tomorrow's day. So by 11 p.m. tomorrow, please do submit all the pending assignments and quizzes that you have. No more further extensions will be entertained. We have received several requests, and that is why we extended the time. But after that, that won't be possible for us. Also, tomorrow will be a holiday. So, Sunday, a holiday. Please complete everything that you have and revise every module that you have. For any queries, please post on the discussion forum. And we hope that today's session was fruitful and understandable and gave you further insights into the topic. Thanks a lot. Have a good day and please take care of yourself. Thank you.
And Bhavya ma'am, I think there is query, so I will be sharing the PPT. You can please pass on to the participants.
That will be great, sir. That will be great.
Okay, so thank you. Yes, sir.
Thank you, Arnav sir.